To create the round shape that we want our buttons to have, we will create a custom subclass of UI button, which will contain this functionality for us. We have to create a new file for this, and can easily do so by right-clicking on our project folder and selecting New File. The file will be a Cocoa Touch class and a subclass of UI button, which is already selected for me here, but if not, you can just start typing the class name, UI button, and it should get auto-completed for you. For the name of our new class, we're going to say circular button. And after clicking next, choose where we want to save the file. But we usually don't have to change this, since by default it is already in the right project folder. If I then create the class, I get this boilerplate template, which already contains an override for the draw method of UI button, which is commented out. But since I only want to specify something for our buttons right when they are loaded and not constantly, I can delete this method and instead add an override for the awake from nip method. If I type in awake or start typing it, Xcode should suggest to override the method, which I can just accept by hitting return. All that I want to do now in this method is make sure that our buttons are circular, which I can do by setting the corner radius property of the layer of the button. So when I type layer.cornerRadius, I can already see the explanation at the bottom here, which says the radius to use when drawing rounded corners for the layer's background. And in order to actually make my buttons circular, I will of course have to use half the button's height or width to achieve this. Which one I choose doesn't really matter since the buttons are square and therefore both equal. So let's assign frame.size.width divided by 2. Like I said, I could also use frame.size.height divided by 2 to achieve the same result in this case. But this only goes for square shapes, of course. I will now have to set another property of layer, and that is layer.masks_to_bounds. Now if I set this to true, it will make sure that no sublayers are drawn behind the button, and the shape is actually circular. That's all we need for our button class as of now. However, I do need to specify that my buttons are offset class, and to do so we're going back to our storyboard file, where I will select all 4 color buttons in the navigator to the left, and be careful that you don't accidentally select the action button as well. Then in the identity inspector in the right column, for the custom class field, we're going to enter circular button. Now if we've done everything correctly, it should also be auto-completed as soon as we type in a capital C. We can then confirm it with enter. This is going to make sure that all of our 4 buttons are actually loaded as circular buttons in the app. In the storyboard, we do not see any changes, but as soon as we will run the app later, we'll see that it actually works. Next, we're going to take care of connecting all of our interface elements, which we've added so far to our ViewController class. By doing so, we make sure that we can actually access and react to our UI elements in code. The easiest way to create said connections is by using the Assistant Editor. We can bring it up by clicking on the icon at the top right with these 2 circles. I now have my storyboard and my interface elements on the left side, and the code from the ViewController class on the right side. To get a little more space, I can also just hide the right column for now, since we won't need it, and then we can start creating our connections. I can also delete the override for the didReceiveMemory warning method and then start with the first outlets. I'll start with the 4 color buttons by control dragging from the first button over to my class. And as soon as I let go, I can specify what I want to create here. Since I want to use one property for all 4 color buttons, I will change the connection type from outlet to outlet collection, which can then be connected to multiple user interface elements. I'll call it color buttons to stress that this property contains multiple buttons, and create the outlet collection simply by clicking on connect. If I now hover over this little circle in the line number area, I can also see which elements are currently contained in this outlet collection. As of now, it's only our first red button. I can also click and drag from within this little circle to other user interface elements in my storyboard to also connect them. And if I do that for the remaining 3 buttons and then hover over the circle again, I should see something like this, with all 4 buttons being highlighted. Next, I want to create an outlet for our action button. So I control drag from the button over to our class, and this time I will leave the connection type with outlet. I'll call my outlet action button, since this outlet only contains the singular button. The rest can stay as it is with the type UI button and the weak storage, so I can just hit connect. Now what's missing for the outlets are our 4 labels in the bottom view, where I again want to create 2 outlet collections, one for the player labeled and one for the score labeled. I'll begin by control dragging from the player 1 label and then selecting outlet collection and calling my collection player labels. I'll then drag from within the little circle to our player 2 label to also add it to the player labels outlet collection. For the score labels, it will be quite similar. I'll control drag from the first one to my class and create a new outlet collection called score labels. And I can then connect it to my second score label by again dragging from within the little circle. This concludes my interface builder outlets, and what I still need are 2 interface builder actions, meaning methods that get called whenever the user interacts with my buttons. I will divide this into 2 separate methods, one for the color buttons and one for the action button. I will again start off with the red button and control drag into my class. This time I'll choose action for the connection type and I'll call it color button handler. The type will be circular button, and the event as well as the arguments can stay the way they are. Touch up inside is just a default event of a button, meaning the user taps on the button and lets go. And the sender argument will later contain the button object, so we can use it in our method. Why that's important will be much clearer later on when we actually implement the method. As soon as I've created the IB action, I will just, as we did with our color buttons outlet collection, make sure the method is connected to all 4 buttons by dragging from the little circle to the remaining 3 buttons. Again, if all of this works, hovering over the little circle should highlight all 4 buttons. And finally, I'll control drag once more from our action button to the class and also create an action for this button called action button handler to indicate that this method will handle input on our action button. The type will be UI button. Events and arguments can keep their default values. A click on connect adds this to our class. And we now have added all the outlets and actions we need from our storyboard. This means that we can now close the assistant editor and return to my standard editor. Before we go back to the ViewController class and start implementing the logic of our application, I will bring back the inspector column and we'll need to add something for all the elements that are contained in an outlet collection of any form. The problem with outlet collections is that they are not necessarily sorted the way that we connected them. What this means is that they may be in the correct order, but they also may appear in a random order that we didn't plan. It solely depends on the way our app loads the outlet collection. However, there is something that we can do. We can sort our outlet collection afterwards, so all the elements contained are exactly in the order we want them to be. The easiest way to achieve this would be to tag our user interface elements. If, for example, I select the first button here, I can, in the Attributes Inspector, scroll down to the section View, which contains a property called Tag, set to the value 0 by default. Now, for our first button, we can just leave it at that. But when we now select our second button, the blue one, I want to set its tag property to 1. The green button will get tag 2, and our yellow button will get the tag 3. This way, our 4 buttons are now numbered from 0 to 3, and we can now use these values to sort our outlet collection. But before we do so, let's also check our labels for their respective outlet collections. For the player labels, I'll leave the player 1 label tag at 0, but set the player 2 label tag to 1. And then do the same process for the score labels, leaving the first at 0 and setting the second to 1. This actually concludes our work in the storyboard. We can switch over to our ViewController.swift file. We want to use the viewDidLoad method, which gets called whenever our ViewController initially loads, to sort our outlet collection arrays, meaning color buttons, player labels, and score labels. We want them sorted so that the elements with the lowest tag are the first ones in the array and the rest follows in an ascending fashion. To do so, I can, for example, write color buttons and set it to its own value, meaning color buttons, but with the sorted by method appended to it. This method is already provided by Swift to sort collections, and we now have to pass a sorting rule in a closure in curly brackets. I can use $0 and $1 to get the two array entries that are currently compared for the sorting algorithm. And since I said I want to sort them using their tags, I'll specify $0.tag is less than $1.tag. All this does now is rearrange my color buttons array so that the buttons are ordered by their tag value. Exactly the same will now be done with our player labels and score labels arrays. So I will just copy this entire expression and paste it 2 more times here. However, I'll replace the color buttons property once with player labels here and then with score labels for the last expression. I also want to implement a quick test for my button handler methods, which is why I add print statements to them. In the action button handler, I'll just print action button, and in the color button handler, I can already test if our sorting with the tags worked properly by writing print button and then appending standard.tag using string interpolation tabbed. This will give me the tab button in the sender parameter, and I can then access its tag property in the print statement to see which button was tabbed. If all this works, we should get the buttons 0 to 3 from top left to the bottom right in our grid. So let's run the application to see if this actually is what we get, or if we still have any errors in our code. our app starts, and first and foremost, we can see our round buttons. If I tap on the action button, I can see the action button output in my console. And if I tap on my color buttons, we can see button 0, button 1, button 2, and button 3 in our console. So the sorting of our buttons array seems to be doing its job, and we can later on assume that the buttons are in the right order. There is a slight problem that I just noticed, and some of you might have noticed as well. If I tap on my buttons, I don't actually get any visual feedback from the application. Now, we currently have our console output in our console, but a regular user of our application would not be able to actually tell if the button was successfully tapped or not, which is a pretty bad user experience. So, what can we do to change this? Let's stop running our app and go into our ViewController class, where we can define our first own method. It will get the name createNewGame, and as of now, it won't have any parameters or return values. To start off, it will only contain a small piece of code. The first thing we want to do is change the title for our action button. I can do that by writing action button and then use the setTitle method that is provided for us by the UIButton class. Since this is at the very beginning of our game, I will add the title start game, and for the control state parameter, I will specify .normal. This way, if we now also call this createNewGame method from our viewDidLoad function, like so, our action button should display start game as its title. Other than that, I want to change a property on all 4 color buttons. And I'm going to use a for loop to do so. So let's write for button in color buttons to iterate over the button array. And for each button, I will then set button.alpha to 0.5. What this does is reduce the opacity of our buttons. And that's really useful for us, since we can now kind of flash our buttons if the user taps them, or we display our color sequence. To actually animate our button taps, we now have to go back to our circular button class and add some code there. What I want to do here is override a property that is called isHighlighted. If I start typing isHighlighted here, it already gets suggested, and I can select this property by hitting the return key. Now all that I need to add to my isHighlighted property is a so-called didSetObserver, which is written inside of curly brackets. Inside of the curly brackets of our didSetObserver, I can specify some code, which will then be executed whenever this property was set. This is the case whenever our user taps on the button, which will then set the isHighlighted property to true, or the user lets go of the button, setting the property to false. I can check this by writing if isHighlighted, in which case the user tapped on a button. I will then set the alpha value to 1.0, meaning full opacity. In the else case, meaning our button is not highlighted and the user has let go, I will reset the alpha value to 0.5. Like I said, this will now be executed for elements of the circular button class whenever the isHighlighted property is changed, meaning a user taps on a button or lets go. To check if all this works, we will run the project again. And if we did everything correctly, what I'm pretty sure that we did, we should first and foremost see our action button now displaying the title Start Game, which seems to work. I can also see that our color buttons are slightly transparent, but as soon as I tap on the button, the alpha value changes and it looks like the button flashes for as long as I hold the tab. Now this provides a clear visual feedback for the user so that she or he has actually interacted with or tapped the button. And the same mechanism will also come in handy soon when we want to display our color sequences.